I've heard great things about RayLib. I've been told it's one of the easiest game engine libraries to get started with, and all you really need is the library, this cheat sheet over here, and maybe a quick look at the examples. So what I'm going to do today is set a small challenge for myself. I'm going to take this scarfy over here and see how easy is it for me to create a simple program that allows me to control scarfy to move him around on the screen. Let's get started. And let's start the clock. So the first thing I'm going to do is to take this example template and make a copy of it in my own directory. So let's go to RayLib Playground and we will call it 2D character. Now we don't need this big comment at the start telling us how to create an example. And we'll leave the rest as is. We want to get moving. So all going well, I push F6, I have a little script that will compile and run it for me. And I should get a window open up. Yeah, congrats, you created your first window. So let's close that. Yeah, thanks to Avast, I get two opens, but that's okay. So let's have a look at what we have. So the screen width and height is set up here. There's a simple initialization done. Set target FPS, we'll leave that as is, and then there's a simple loop. So while the window shouldn't close, that means nobody pushes the little X or the escape key, then we, in a loop, do this. So let's get rid of this congrats message. We're going to add our own drawing code to that, and let's change the title of the screen title to 2D character. 2D character animation. And there's little point in doing this, but if I compile and execute that, you'll see the changes. We'll have a completely empty window with our new title in it. So that's all good. Next, I'm going to need our little character, Scarfy. So under examples, he should be in the textures resources. There's Scarfy. So let's copy Scarfy over to our playground. Just dump him in there. And then let's head to our cheat sheet. How do we load a texture? And if this is as logical as I expect it to be, it should be load texture. Yes, texture 2D, load texture. So we will start that. We will do that before the main loop. Texture 2D, scarfy text equals load texture. And then the file name is, what was it again? Scarfy.png. So that will be loaded into VRAM. And then down here we have a draw texture, and we can draw it at any position, and then we have a color tint. So clear background. Let's just draw the texture at, because we're doing this roughly 0, 0. Actually, no, let's do halfway down from the top of the screen. Or down the bottom of the screen, actually. Let's put it down the bottom of the screen. And wait, let's check what so texture first, then the position, then a color tint. So draw texture Scarfy, Scarfy text there, and I'm not sure what the color is. How do we create a color? Might actually be easy to look at an example for this. Let's see what happens. It'll probably complain. Yeah, it doesn't like that. The compiler doesn't like that. Okay, so the cheat sheet is actually not that easy. Alright, so we can use get color hex value. Let's see what happens. Oh, it still doesn't like that. Yeah, when programming you will get the compiler telling you what you're doing wrong all the time. So this time it has built and we don't see anything. Maybe I pushed it too, yeah, I probably pushed it too far down. So let's take the screen height divided by 2 and we run the new version. Okay, I still do not see anything, which means I think I'm better off looking at the example. So yes, they load scarfy as well. I'll script down to there. Oh, okay, so there is a preset white, is there? Or did they invent that? We just use that and position. They have a draw texture, scarfy 1540 white. So let's try that. Preset white, delete R1. No, we still do not see anything. So now the usual tricks is to just copy what they were doing. And step by step you should end up with something that works. Okay. Alright, I'll pause this so you skip the boring bit where I'm trying to figure out what's going on. Okay, so I've got it working now. The problem was my build script was slightly wrong and it wasn't loading the textures. It's my fault for building a custom setup instead of just downloading and using the pre-built binaries, and also for having no error checking. So no indication that the texture wasn't loaded. If I checked for that, mind you, their example doesn't show you how to do that either. Anyway, moving along, we have all the frames. There are 6 frames in this animation. In order to be able to show one at a time, we need to show a single rectangle, and each rectangle is a 1/6 of the texture's width. So let's start coding that. So frame width equals scarfy text dot. Let's just have a look at yes, okay, so the texture has a width. They actually use a rectangle, so I'd be inclined to use that as well. Use the frame rec. Actually no, let's stick with this. Width divided by 6. And now we want to, instead of drawing the whole texture, we want to draw a rectangular area. So draw texture, rectangle, and a vector 2 position. Right, so we will end up creating a rectangle anyway. So maybe we should just use their frame rec. Yeah. Now we are going to change draw texture for draw texture rec. We are going to need a 2D position. So vector 2D, let's call it scarfy position. Let's put scarfy, well, not in the middle, but close to the middle. Screen width divided by 2 and screen height divided by 2. And then we change this to draw texture rect. So first the rectangle, then the position, then the tint. So frame rec goes next, and then the position. Well, let's just try running that. Oh. Still have the old one running in the background, of course. Stop that and run it again. So what did I do wrong? In the interest of saving time, let's just copy their vector 2. Oh, of course, vector 2D. It's vector 2, not vector 2D. Let's try that. And now, if you're somebody who does not like being told that you're wrong a lot, you shouldn't take up programming. Okay, and there we have it, first frame. And now we want to animate it. So to animate it, we need to update frame rec. We'll update the X position by 1 frame width. So let's still have the frame width variable. Should just make an integer. And put that in there. And now we need a frame counter. And we will update that. They say we should update our variables at this point, so let's do that. Let's increment the frame counter, and then I'll just create a num frames variable, because otherwise we keep entering 6 all over the place, and that's not good. And then we'll get rid of the 6. For code readability, we want, as usual, prefer to use names where possible, and we don't want to have the same thing all over the place, so that we want to have, if there's a variable, we want it in one place so that we only need to change it in one place. Whereas if we had the 6 everywhere, if we change the number of frames, we'd have to change it everywhere. Now we need to update frame rec. The X position of frame rec. So the X position of frame rec equals frame width times, let's change it to frame index instead of frame counter. I think that describes better what we're doing. And let's run it and see what happens. Okay, way too fast. Let's slow this down. So we should have frame, let's call it a frame delay counter, and a frame delay. So if we're running at 60 frames a second, let's try slow it down by a factor of 5 and just see what happens. So increment the frame delay counter. If that's greater than frame delay, then we update the frame of our animation. Oh, and of course we need to reset the frame delay counter back to 0. Okay, that's a bit better. Okay, now see scarfy running. Now we need to be able to read the keyboard. So I think we can check the example quickly to see how to do that. Okay, so you've got the key left and key right, so let's just copy and paste that in. I don't want to change the frame speed though. So we will change this to our own code. We have, when the character is walking left, we want to flip the texture around. And when the character is not moving, we want them to just stop. So seeing as this is a quick example, I'm not trying to do anything perfectly. I'm going to add another variable which is called moving, scarfy moving. So let's only update the frame if scarfy is moving. Otherwise, should stay the same. Just stay paused exactly where he is. Yeah, let's see how that behaves. Right now he should be back to just being stationary if we run this. Yeah. And then scarfy, if the key is pressed right, then scarfy moving equals true. And let's see what that's, so let's push right. And yes, when I push right, he moves. So at about 24 minutes, we are able to, oh, he's not stopping because I haven't added code to stop. But we have our first keyboard response. So first user interaction. So let's correct that. Scarfy moving equals false if, scarfy moving equals false if no key is pressed, and scarfy moving is true if the left key is pressed. I can also already tell you that I'm not happy with that because we also need to indicate which direction scarfy is going to be moving in. Oh, now it's not reacting at all. Wonder what's happening there. Why would that be happening? You know, it might be the case. Let's see, is key pressed? Ah, yes. What I actually wanted to do is have the character walking when is key down. I don't want it to react to just presses. I want it to keep moving while it's pressed down and then stop when he's not moving. So let's try this. Okay, yes, now it's reacting the way it should. I hold down the right button and he's walking. Hold down the left button, but he's going in the wrong direction. So, progress. Next, we want him to actually move. So we have our scarfy position, and this is where I think should call this scarfy velocity really, and maybe switch that to a vector 2. And then let's just, in our update section, we will add code to move. So update scarfy position. Okay, here it is, vector 2 add. So I can update the position with vector 2 add. So every frame we add scarfy velocity, and then up here we need to set the scarfy velocity in response to what the user says. And I think up here we also need, I should actually put all the constants up the top here. Scarfy walk speed. That's maybe a bit long. Let's just cut it down to scarfy speed. I have no idea what looks good or what would match the animation. And let's start with 5 and see what happens. So instead of scarfy moving here, now we change the velocity. The x-axis velocity to equal scarfy speed. And we do the same thing for the left key except negative. Let's see what happens there. Right, scarfy moving false. Instead of that, we should be setting the velocity back to 0. And then instead of scarfy, actually no, let's create a scarfy moving. And so if the scarfy velocity in any direction is 0, then we are stationary and not moving. We are making slowly implicit declaration of function vector 2 add, so we should be including RayMath. Okay, it's already. So our checking if it's 0 is not working because we have inverted logic. Let's correct that. So scarfy moving means that this is not equal to 0 and this is not equal to 0. And this is all very rough, but the goal, the challenge here is to get to a simple okay. Of course, yeah, this is what happens when you try to do things quickly. The logic is if either of them, either the x or the y-axis are not 0, then we're moving. Scarfy is moving. Next task is to make sure that when he's going to the left, that he looks left. So let's see if we can we flip the direction? So just a rough test. Frame rec dot width. Actually, I should put an if around that. Otherwise it'll flick back and forth like crazy. So what I'm doing now is I'm flipping the rectangle width to be negative, and I'm hoping, because I have no documentation that says it will, but I'm hoping that that will flip the texture around the other way. So flip it horizontally. Oh, and it does. Oh, nice. Of course, I need to flip it back the other way when I push the right button. So we just copy this code over and say if the width is negative, then we flip it around again. And now we have Scarfy. I can control him in any direction. And the timer is at 35 minutes. So it took me just over half an hour to get this done. Conclusion, yeah, RayLib is quite easy to use. It's quite, at least for the basics. The examples are pretty good, and the code is the functions in the code are pretty easy to follow. If you want to experiment with RayLib yourself, the easiest way to get started is to click the download button on the RayLib homepage and to just download and install one of the pre-made binaries. I didn't do that because I have my own compiler setup already done, but that's the easiest way. So that's it for today. I will see you next time.